progressive decrease in the amount of energy in our battery. Same if we now look at what happens during the recovery interval. So again, with an appropriate recovery that's enough for the energy stores to be recovered between the exercise bouts. If for any reason, as in the middle panel, the recovery is shortened, that won't be enough to refuel the stores, and that will lead progressively to a decrease in the energy available. And or if in that case it's more the intensity of the recovery intervals that is increased, we have the same outcome, meaning that an inability to properly refill the energy stores in between the exercise bout, leading as well to a battery almost full at the end of the set. And this concept is pretty important when it comes to designing the best formats. Because as you can see, if intensity is too high, if the duration of interval is too long, if the recovery is too short or recovery intensity is too high, it will be very difficult for athletes to train for more than a few minutes. And that becomes problematic if we want to spend some time in the red zone. So it's a pretty complex fine-tuning combinations of finding the right adjustments so that athletes, players can train long enough to spend some time in the zone, but not 2 hours either because we don't have time. And conversely, if they don't train long enough, if the exercise is too difficult, they won't have time to spend some time in the zone and create those adaptations. That's why it's important to provide some general guidelines, and that's going to be the last slides of these talks, about how do we generally build these different weapons or formats. So for the example of long intervals, generally we use intensities between 95 and 05% of the speed reached at the typical incremental test of VO2 max. We use 80 to 90% of VIFT, for example. Duration, 2 to 5 minutes. Recovery, 1-4 minutes, most of the time passive. So with those intensity in mind, whichever high intensity long intervals you implement, you might be more or less able to run a proper session. If you're now using short intervals, you see that the intensity are a bit faster than with long intervals. So it's more 90, 105% of VIFT, 100 to 120% of the incremental test of maximal speed. Duration, 10 to 16 seconds to 60 seconds. Rest, same duration. Recovery could be different options. Most of the time, we recommend using passive as well. Repeated sprint training. Most of the time, in terms of intensity, there's nothing to think about at the end for those formats. It's just about sprinting as fast as possible. Sprinting for 3 to 10 seconds, with rest generally passive as well, between 15 and 60 seconds. Sprint interval training, that's something that I haven't been used as much personally, but you'll have other lectures from other lecturers like Alberto Menez Villanueva, for example, and he will talk more about these formats. But generally, these formats are also about all-out sprinting for 20 to 30 seconds with way longer rests in between, generally passive recovery. Then the last format that we're going to discuss a lot in the next part about the application and the utilization into the real football context are the game-based formats, so the small-sided games, which are more or less like long intervals, but it's a modality that changes. So instead of just running, they involve playing against other players. So they involve balls, decision making, and so on. And in this specific context, the proper intensity is not dictated as while running, but it's just dictated by the game constraints. So now we have presented the different formats. We discussed the types, the different physiological targets, how those different formats can be prepared, used, and which are the targets that can be hit with these different formats. And we're going to just go a little bit further into the analysis of those responses and how we came to those conclusions when it comes to select the right weapons or formats for our training context, as for example, these microcycles. So when it comes to look at the acute responses to repeated sprints, for example, we've done a bit across the world some measurements of the VO2 responses, acute responses, gas, lactate, neuromuscular. So you can see on the top left a guy repeated sprints on a treadmill so that we can have the force impact as well to have an idea of the fatigue that occurs to the legs when he repeated sprints. On the right side, the guy is actually changing directions on force plate, so we could also see how fatigue develops with change of directions. In the bottom, you have another example of assessments of the repeated sprints responses in a lab in France. This is an example of sprint interval training on the bike. We've done the same measurements while running. Again, with always the same idea of trying to quantify, to be able to compare after aerobic, anaerobic, and neuromuscular responses of those drills. That was probably the first time that the aerobic demands were measured during small-sided games. In this case, it's handball, and you could see that those guys were actually playing 4x4, while each of them wearing a K4. All details response to each of those formats are provided in these two reviews that are accessible online. So I just wanted to finish this by summarizing the different demands of those different formats in terms of, as we always discuss, aerobic, anaerobic, and neuromuscular demands. So in terms of time spent in the zones, as you can see very clearly, the formats that allow people to spend a fair amount of time in the red zone are actually the low intervals and the long intervals and the short intervals. These are pretty clearly, in terms of run-based demand, the only intervals that allow players to spend time in the zone. On the other side, as we alluded to a little bit initially, small-sided games are pretty interesting to spend some time in a zone while not exercising for too long. In the middle, repeated sprints training and sprint interval training did not allow at all, or not much, players to spend some time in the zone. Anaerobic glycolytic contribution. I like to say that most of the time, and this is a pretty funny sentence or quotation, saying that in nature, animals most of the time who stop and start tend to win the race. That relates to the way anaerobic contributions is actually involved into energy metabolisms during exercise, and that it's the rest that really makes the difference. So the more the rest, the lower the anaerobic contribution overall. So for that reasons, with short intervals, there is an ability to actually target or stress way less the anaerobic contribution than with long intervals. With repeat sprints as well, you can see that the range of glycolytic contribution can be way different in relation to the length of that rest between the sprints. So when we have sprints with short rest, the anaerobic contribution will be very high. When we have sprints with long rest, the anaerobic contribution can be pretty low. For sprint interval training, anaerobic contribution tend to be always pretty high because those long sprints are actually triggering a lot the anaerobic contribution. While interestingly, for many reasons, small-sided games are often associated with a lower anaerobic contribution, which is overall something pretty important in our context. Again, that's going to be discussed in the next part about the actual programming in practice. But small-sided games are often associated with low anaerobic contribution, which make them a very important tool for us when it comes to using some of these formats within the training week. Last part, the third of our targets, the neuromuscular responses. So when we discuss about the neuromuscular load of a session, it's pretty difficult to give you a summary as we've done for VO2 max or for the time spent at VO2 max or the anaerobic contribution, because there are more measures to assess neuromuscular load and a lot of variations between the different exercises and also the response to the individual response of players. So instead of giving you a summary to compare the different formats, I think it's still worth trying to find a way we can predict in a way we implement those implement those exercises to kind of create or variate the level of neuromuscular load. So a session that will include high-speed running, sharp change of directions, some jumps and so on will obviously involve a high level of neuromuscular load. Other sessions which might be run on the grass with submaximal speed, with slow turns, will obviously be associated with way less neuromuscular demands. If we can have the parallel between running and cycling, for example, for cycling it's way easier. Low cadence means higher load, neuromuscular load, while an average cadence will diminish the load as well, and a high cadence will be oppositely linked to increased neuromuscular load, but because of the speed component. So for cyclists, they take it a bit more easier. Slow for strength, high for speed, and in between for none of both. In football, obviously, it's way more complex than that, so it relates way more to the way you design the exercise, and we're going to see that in the next part, and how do we implement that into football-specific drills. So to summarize this heavy and dense first part, we have initially briefly discussed the importance of fitness for the overall performance, and we believe, or I believe especially, that this has to be considered at the individual level, and obviously there are players that will require more than others, some additional conditioning. But now when it comes to implement and to choose the right format or the type of training, long intervals, short intervals and so on, obviously it becomes very difficult to choose one from another, because on the long term, most of the time, those different programs allow more or less the same type of improvement when it comes to cardiovascular fitness. So my take is rather to look at the specific acute responses of those different type of intervals to better understand and to better choose the right one fitting in the context of the concurrent training or the different adaptation targeted throughout the training week, for example. And on that matter, the tactical periodization paradigms can help a lot in selecting some appropriate type targets. And with the type targets, I've been discussing a lot on the physiological aspects that are targeted through the different sequences, like the type 1 targets, which just target the aerobic system while trying to keep lactate production and neuromuscular load pretty low. We have on the other side target 4, for example, which targets all the systems simultaneously, aerobic, anaerobic, and neuromuscular. Obviously, those types of exercise, types of targets needs to be chosen to be used at the right time, at the right moment into the microcycle. To hit those different types, we're going to have to use the right weapons. And in that case, the different weapons can be manipulated a little bit. And for example, for type 1, you might have to use especially short intervals. But if you want to target all together like a type 4, you could use repeated sprints. But it's probably better to think first about the type and then select the best weapon to make sure you end up by touching the qualities that you really require, rather than starting straight by the weapons. And as we discussed often, those weapons, most of the time, we assess those 3 levels in terms of aerobic demands, lactate, and neuromuscular. In terms of VO2 max response, it's clearly the longer intervals that have the greater chance to touch these targets. When it comes to lactate participation or neuromuscular load, it really depends on how you manipulate those different weapons. Low and high lactate levels can be reached with short intervals. Depends how you manipulate them. Neuromuscular load, same. With short intervals, you could touch high or low neuromuscular demands, and again, it's your call, your decision to design them to make sure you touch or you target more or less those qualities. But again, it's more the principle of understanding and identifying the target that you really want to touch before implementing and selecting the right weapons. So tailoring is key in relation to the context and the context of football, as we're going to discuss in the next part.